Okay, so in this lesson, we are going to solve systems by using substitution. So that means we're going to plug in one of these equations into the other. Keep in mind that since we are solving with systems, we are going to still have three options for our answer, just like when we were solving by graphing. You can have one answer and it's a coordinate point. You can have no solution, or we could have infinite solutions. So let's take a look. We want to solve for one variable in one of the equations. So look at this one. The y is already alone. So we don't actually have to get anything alone in this case. We're going to go ahead and plug. So I called this one the game, and this one kind of like the player y. So in the game, I'm going to replace position y with this right here, this other player, because they play that position y. So I'm going to substitute that into the other equation, and then I'm going to solve. So what that looks like is I'm going to write this out, x plus, and then instead of y, I wrote out the entire equation of the game, and then I'm going to replace it with what y is in that equation up there. So x plus 2. And then I'm going to go ahead and solve. So I'm going to take away my parentheses that was just there to kind of hold its spot. So no distributing. We're going to go ahead and combine like terms, x and x to x, and then we're going to subtract 2 and divide by 2. So x equals 3. So we're halfway there. We've got one part of our ordered pair solution, the x, but I need to get the y. So I'm going to go back up, and it doesn't matter which equation I use. However, it might be easiest to use this first one because it already has y alone, and we want to figure out what y is. So I know that y equals x plus 2, and in this case, we know that x is 3. So I'm going to go ahead and plug a 3 in here, and 3 plus 2 means I've got y is 5, and I've got my answer. So let's take a look now at some practice problems here. In our first one, I don't see x or y alone. So I'm going to look to see where can I find an x or y maybe that doesn't have a coefficient. Ooh, right there. So can I get that x alone? Yes. Let's go ahead and try and get that x alone. It's pretty easy since it doesn't, again, have a coefficient. We're just going to subtract that 2y. Now I have x equals negative 2y plus 4. So I know I'm going to replace position x, but I'm going to do it in this game here. Like basketball game, we've got tired player x. So I'm going to pull that player x out, and I'm going to put in this new player who plays position x, and I'm going to put that in right here, negative 2y plus 4 instead of that x. So now I'm going to go ahead, and I do need to distribute because this 3 is in front of the parentheses. So it's negative 6y plus 12 minus 4y equals 7. And then I'm going to combine my like terms, add those together, they're on the same side. So that's going to give me negative 10y plus 12 equals 7. And then I'm going to subtract 12. Negative 10y is equal to negative 5. And then I'm going to divide by negative 10. So this right here, if we think about if we pulled a 5 out of both of those, it would be 1 over 2 or 1/2, and it would be positive. So y is equal to 1/2. And now we're going to plug that half back in because I don't know what x is. And we can plug it back in to maybe that top equation. So 2 times my y, which in this case was 1/2. And then it was plus x equals 4. So half of 2 is 1. And then I'm going to subtract the 1 to get x alone. and x is 3. So my answer would be 3 because x comes first in my coordinate pair, and then 1/2. All right. I don't think number 2 is very pretty. So we're going to move down here to number 3. So if you want to try this one on your own, go for it. You can pause and then check and see how you do. I suggest getting that y alone. Since all the rest have coefficients, I would get the y alone. So go ahead and try it, pause, check, or you can follow along with me if you're just not quite sure yet. So now I've got my y alone. I know I'm going to replace this y right here with this. So it's going to look like 6x plus 3 times, and then I'm going to replace the y with negative 2x minus 6. I need to do some distributing. So 6x minus 6x minus 3 times negative 6, negative 18. And then, 6x minus 6x is 0 x's. There are no x's. So we're left with negative 18 equals negative 12. There's no variables. So this is a false statement. That is not true. And when we get a false statement with no variables, so if there's like x equals 0, you have a solution, plug that back in. But if you get no variables, no x or y, then you have false, no solution. If it's true, it would be infinitely many. So go ahead and try number 4. You can pause, check when you're ready. I would get that y alone. Make sure it's a positive y, so maybe move it over and then move your 3, undo your 3 to the other side. So like add y, and then add 3, add 3. So that's going to give you y equals 5x plus 3. Now we can plug that in for that y. So it looks like 15x minus 3, and then instead of position y, that player takes a timeout break, and then this player subs in for that position. And we keep everything else the same. The only thing changing is that y is changing to that. And then we're going to distribute. Okay, we've got that again. 15x minus 15x is no x's. And then we have a true statement. So if it's true, then it is infinite solutions. And those are our 3 types that you will see with systems.